Welcome to the presentation today, where we'll be covering the various activities which the security working group has been involved in. I'm Ruchika Gupta, the technical lead for the SWG group in Linar. In the agenda today, I'll be covering in the general updates, and I'll have various members from the team join in and talk about the activities they have been involved in and the next steps in the future. One of the major projects which the SWG team has been involved in is with the development and maintenance of Opti. In late 2019, the ownership of Opti was transferred from Linaro to trustedfirmware.org, which has been its governing body since then. We at Linaro are still active contributors and are responsible for scheduling the releases with the security incident process and driving the roadmap. Having said that, Opti has a very active community upstream, and we have support for approximately 30 different platforms, and which is available, and an active contribution from various companies. For some of the noteworthy contributions which have been recently merged in the Opti project include the extension of the crypto firmware framework with the hardware accelerators by Clement from NXP, the SE050 plug-and-play driver from Foundries group. Then we have the T-supplicant plugin framework, which has been added by Alexander from ON Prussia, and then the Opti hardware RNG driver, as well as the T-based trusted key support added by Sumit. For the project, we have a monthly meeting, which is scheduled every last Thursday of the month. And the details of the meeting, the previous meeting recordings and notes are available on the slide. It's an open meeting where everyone is invited to join in and bring up any topic they wish to. Moving on to the next feature, which we have been involved in the development of, is PKCS 11. It was Hong Kong 2018 Linaro Connect, where the feature was first presented in the form of SKS. Now the feature is being cleaned up, reviewed, and lots of patches have been merged in upstream as PKCS 11 TA. The features which are currently available include object management support, session management support. We have symmetric cipher support available, key generation, random number generation, and there are few pull requests like digest, etc., which are currently in review. For testing, tests have been added in PKCS 11 as X-test, and we're also using PKCS 11 test suite as well as soft HSM for the testing. Next, in future, we have plans for adding the support for key wrapping, unwrapping, as well as RSA ECC key support and other symmetric ciphers. And the documentation also would be enhanced to add in the PKCS 11 library details in it. Here, I would like to thank in active contributions from Gabriel, Vesa, and Robin, and who have been very active in contributing to the PKCS 11 project. Vesa recently added the support for T-based authentication support in PKCS 11. More details on the activities in this area and the design details, etc., are available in another Connect presentation scheduled at 11:30 UTC on 23rd of March. So please join us over there. Now I'll hand it over to Jens, who will be talking about the GPT APIs and the secure partitions. Over to you, Jens.
Hi, I'm Jens Wiklander from Linar Security Working Group. I'm also an Opti maintainer. Today I'm going to talk about a few features I've been involved in recently. Global Platform T Compliance Test. Starting from Opti version 3.11, we have updated the X-test framework to support the latest Global Platform T Compliance test suite. The X-test framework is normally used to run the regression test suite. With this, we gain one more test suite. Global Platform runs a certification program where vendors can get the devices T-certified. Part of the certification program is to pass a certain amount of test cases. One way to make it easier to pass the certification is to run and ensure that the GP test suite passes with no regressions. These tests are included in our current CI iBot, so it no longer just runs the publicly available regression suite, but also the GP test suite when people are sending patches upstream to the Opti project. The GP suite also provides additional test coverage, so it makes sense to run under all circumstances. Xtest can be compiled with the GP suite by adding GP package flag to make, pointing to the previously downloaded GP test suite, a 7-zip file. Note that the GP test suite is not free, so we can't include it directly in the Xtest Git repository. The package must instead be supplied separately. The package is free for GP members and can be purchased by non-members. Next, Stmm with Opti. Standalone MM is an EDK2 application used to store EFI variables, and here in Opti Secure Storage. Due to limitations of the currently available platforms, it's only possible to run a single payload on the secure side, SecureEL1. As a stepping stone to future architectures, Linar, in collaboration with ARM, have added support for running Stmm in Opti. The changes to Stmm are quite small. Instead of running as a bare metal binary, it runs sandboxed at SecureEL0. Special syscalls are used to access the Opti Secure Storage, which in this case is implemented in RPMB. In Opti, there's a bit more changes. Support for running secure partitions sandboxed at SecureEL0 or secure user mode, a bit like a trusted application is run, but with a different environment, where the standard TA syscalls have been replaced with special syscalls just for Stmm. A SWG interface has also been added to pass the MM messages back and forth. Next, FFA and secure partition updates. FFA, or Firmware Framework for ARMv8A, is a specification that describes a software architecture for virtualization in secure world as well as in non-secure world. It includes a standardized way of passing messages between different components. From ARMv8.4, a secure EL2 is defined, where a secure hypervisor can reside. This secure hypervisor is part of the secure partition management and is called SPM Core or SPMC. As a first step, experimental support was added for this on the OptiPort to the QMOV8 Vert platform. In this prototype, we are replacing the raw SMC-based communication with calls to the FFA interface. Since this platform doesn't have a secure EL2, we placed the SPMC in Opti at SecureEL1 instead. This has allowed us to try out the protocol while keeping the other changes as simple as possible. This was merged in June last year and has been updated a few times since then. Note that this is experimental and we may still need to make changes to the API. Another ongoing effort is to add support to run secure partitions at SecureEL0 or secure user mode. This resembles the previous Stmm effort, but aims to follow the FFA specification instead. It should, for instance, be possible to port Stmm to run as a proper secure EL0 SP when this is completed. Finally, we are also working on running Opti as a secure partition at SecureEL1 underneath Hafnium as a secure hypervisor at SecureEL2. This prototype is currently based on the FFA v4 patch set, which was posted recently on the Linux kernel mailing list by Sadip Holla. On top of these patches, we have added a few patches to the Opti driver, replacing the SMC calls with calls to the FFA interface instead. This was all for me. Thank you for listening.
Thanks, Jens. Hi. Over the past year, we have merged in OptiOS the SCMI message drivers with supports for clocks, reset controllers, and voltage regulators. SCMI is an interface between an OS and a remote firmware that controls resources like power domains, sensors, clocks, and more. The SCMI specification defines protocol messages between an SCMI client, the OS, and an SCMI server, the firmware. As I said, there are protocols for various resources: power domains, clocks, voltage regulators, reset controllers, and more. Messages allows clients to discover resources, query, and modify their states, as enabling a clock or setting its frequency. The fact is, with Opti, the hardware is partitioned between non-secure and secure world. And because of that, there are platforms where some system controls must be accessed from the secure world, despite the resource itself may be used only by the secure world or shared between the secure world and non-secure world, like PLL for clocks, for example. For such resources, the secure world shall implement a driver and expose the software service to non-secure world. This is where SCMI may help in Opti. Linux kernel has a SCMI client driver since a while, and we recently merged in U-boot an SCMI client driver also. With SCMI message drivers in Opti, a platform can easily implement an SCMI server. The SCMI message drivers decode the message and calls the platform driver handler functions. SCMI message drivers are rather simple. They are dedicated to simple SCMI scenarios, getting a clock, setting a voltage level. However, SCMI provides support for more complex scenarios with notifications and other asynchronous events. Linar is working on the porting of a full-fledged SCMI server in Opti and other environments. You can find some links in these slides. Well, thank you. And now Victor for some Opti 100 news.
Now, we'll discuss some updates regarding AOSP and Keymaster for Opti. This is the current state of the reference AOSP builds for Opti developers. We have a high-key AOSP dev build based on the master branch. This is cloned towards the end of last year and integrated with an Opti build based on version 3.9. For this build, there are some regressions in Xtest and the Google test suite for the Keymaster version 3 help. We have a set of scripts that build the bootloader firmware and Linux kernel along with the AOSP user space images. Due to tighter restrictions in the build system and general volatility of the master branch, we also have a high-key AOSP stable build based on Pi version 9, integrated with an Opti build based on version 3.12, which is currently the latest release. For this build, there are no regressions. The high-key 620 board is end of life, and support for it has been removed from upstream AOSP, so we don't have a current build for this. Our Opti-based Keymaster Hell implementation is at version 3. Gatekeeper Hell is at version 1. From time to time, we get bug reports from security researchers for our implementation. You can find the advisories for these reports at the link shown here. If you have an Opti-enabled AOSP build for your platform and wish to enable file-based encryption, you have to make some platform-specific changes as well. Please refer to the SAN 19-226 presentation for further details. Some details in the slides, for example, the path to the non-standard partition, are outdated, but the overall concepts and ideas still hold. Our testing strategy with regards to the reference builds is first and foremost Xtest, as usual. We also run the standard Google test suite for Keymaster and Gatekeeper hells. Normally, we just run the executable directly from the console, but you can launch this test from the VTS frameworks as well. We also have our own Google test suite that runs a couple of other tests that aren't in the standard Google test suite. For example, verifying the minimum time between operations or maximum users per boot for each of the key that's generated. These are configurable parameters that users can specify when generating a key. We have the ability in our Linar continuous integration and testing framework to automate both the building and testing of these reference builds. So we're not only able to detect just test regressions, but build errors as well. For future improvements, we would like to update the stable build to use the master branch and do development on it as well, like all the other Opti repositories. This way, we don't have to maintain multiple versions of builds. We would also like to implement support for the Opti driver in GKI-enabled Linux kernels. Since we currently don't have any sponsors for work in this area, the builds might remain in the current state for the near foreseeable future. So community contributions are more welcome than ever.
Okay, hi, I'm Joachim Beck, and I'm going to give a short update covering the work we have been doing with Widevine and also a few words about the security incident process. For those not familiar with Widevine, it's the DRM architecture running on Android-based devices, protecting copyrighted media from unauthorized modification and distribution. Sometimes you will also hear people say OM crypto when referring to Widevine. Linar have, with members, created a Widevine implementation a couple of years ago. Back then it was based on the OM crypto v11 specification. However, since the OM crypto v14 had changes no longer backwards compatible and we weren't fully happy with the old implementation, we decided to do a full rewrite. And this took place roughly a year ago. What we ended up with was a quite nice and clean Widevine implementation for Opti following the OM crypto v15 specification, where all patches have been carefully reviewed and tested. The implementation was done in collaboration with one of the Linar members and has been thoroughly tested on their hardware. Having said that, what we believe is extra cool this time is that we are able to run everything in a QEMU-based environment, and that includes the test suite from the Widevine test itself. And as a consequence of that, you will be able to easily do debugging with GDB, which of course simplifies bug hunting and overall development quite a bit. Likewise, the turnaround time for an edit, compile, deploy and runtime cycle is very short. Widevine comes with the Widevine license agreement, so it cannot be publicized as an open source project. But Linar happily shares the implementation with Linar members who already have signed the VLA with Google. Next thing, well, let's talk a little bit about the security incident process. When the Opti project transitioned to Trusted Firmware project, the security incident process changed a bit as well. In the past we had a single group of trusted stakeholders and we had a hard 90-day embargo period for all issues. The Trusted Firmware project have tried to align the security incident process across the different sub-projects like TFA, Opti, Embed, TLS, etc. So it should be the same procedure to report security issues no matter the project. There are now two categories of stakeholders, ESS and trusted stakeholders. Trusted firmware decides who should go where, but most companies would end up in the trusted stakeholders category. But in some cases, companies might end up in the ESS list as well. The difference is that the ESS is notified and can request an embargo lasting up to 14 days before the trusted stakeholder gets notified. After the ESS embargo, the trusted stakeholders gets notified and can request a similar embargo if needed. A big difference for the Opti project is that the mitigation patches can end up on the public tree sooner than what it did in the old process. But having that said, I mean, we never intend to publicize patches so that we put the Opti users at risk. Even though the process is documented at trustedfirmware.org, we believe it can be a bit hard to follow, so we will try to simplify a little bit more in the near future. To become a trusted stakeholder and get on the list, the company needs basically to send a registration request, and exactly how that can be done and what it means can be found at one of the Trusted Firmware security pages. Thanks.
So here is a list of few items in our backlog which we are planning to work in near future. One is to extend the support for virtualization which exists in Opti. Thanks to Waldemar from EPAM for adding this support. We want to get this this feature working on Chemo and add it to our CIs for the convenience of others. Next, we want to explore how the mediator, the T mediator, which exists for the support in Zen, can be converted to an FFA-based mediator, which is T independent. And then further work is required on the support to explore how the hardware resources can be shared. There has been a proposal from Waldemar for the same. We want to continue and extend that work and any future work related with FFA for the same. Then there's plan to add support for asynchronous notification to the secure world. This would be for the pre-version 8.4 cores which do not use FFA. And then there's another area which we're planning to explore that is related with the functional safety. So now with the use of Opti in automotive as well as industrial areas, we have seen requests coming where people have been asking us about the compliance for Opti. So we want to look at that, explore how or whether it is possible to make Opti functional safety compliant, ASIL compliant, what it would take to do that. Any contribution and ideas on any topics, on any of these topics or new topics are welcome. Here, I would also like to thank all the members who have been actively contributing to the Opti project. So Opti is a very active project on GitHub, and we have lots of people contributing to the same. Special thanks to Jerome, who is one of the very active maintainers and contributors to the project. So thanks for listening to us today. And here is a list of sessions which are planned in Connect and are related with security and Opti, which we've compiled for you. Now we're open to any questions which you may have. Thank you.